Welcome to my channel. In this video, we are going to look at the laws of logarithm. We are going to see different situations on how to apply these laws. So we have a list of examples. The first one is number 1. Express the following in logarithmic notation. So in a logarithmic notation, we have log to base a of b is equal to n, where a is the base, b is the number, and n is the power or the log. So in this case, we'll just take a as the base because this is what is raised to that particular power. So we'll have the log to the base, and in our case the base is 7 and the number is this. So that is 49, and that should be equal to the power, which in this case is 2. And part B, we have 10 raised to the power negative 2 is equal to 0.01. So just identify the base, and in this case the base is 10, the number is 0.01, and the power or the log is negative 2. So just going to have it in the form a raised to the power n is equal to b. That is what we have here. So it means in log notation we're going to have log to base a, in our case a is 10, of the number, in our case the number is 0.01, that should be equal to n, which is the power negative 2. Part C, we have 9 raised to the power negative 3 over 2 is equal to 1 over 27. So just identify the base. The base in this case is 9. The number, in our case the number is 1 over 27, and the power is negative 3 over 2. So we're going to have the log to base, which is 9, of the number, which is 1 over 27, is equal to the power, which is negative 3 over 2. Example 2, express the following in index notation. So we have part A, log to base 5 of 625 is equal to 4. So we just identify the base. The base in this case is 5. We identify the number. In our case the number is 625, and we also identify the power or the log, which in this case is 4. So just going to write it as the base raised to the power 4 is equal to 625. Part B, log to base x of y is equal to 2. So in this case the base is x, the number is y, and the power is 2. So we have the base, which is x, raised to the power is equal to the number. Part C, log to base half of 4 is equal to negative 2. So we have the base as half, we have the number as 4, and we have the power as negative 2. So just write the base, which is half, raised to the power, which is negative 2, is equal to the number, which is 4. Example 3, simplify part A, log 3 plus log 4. So we're going to apply the first law of logarithm, which says that if you have the log of a plus the log of b, that should be the log of the product of a and b. So in our case we have the log of 3 plus the log of 4, that should be equal to the log of the product of 3 and 4, which is just the log of 12. Part B, log 30 minus log 3. So here we apply the second law, which says that the log of a minus the log of b should be equal to the log of the quotient of a and b. So in our case, the log of 30 minus the log of 3 is the same as the log of 30 over 3. So that is the same as the log of 10. But the log of 10, since it is a power of 10, that is the same as 1. Part C, log 2 plus log 6 minus log 4. So here we're going to apply both the first and the second laws. So for the first part, we're going to apply the first law, which says that the sum of logs is the same as the log of the product of the numbers. So in this case, we're going to have this as a log of 2 times 6 minus the log of 4. Now between these two, we are going to apply the second law, which says that if there's a difference of logs, that's the same as the log of the quotient of the two. So it means this is the same as the log of 2 times 6, that is 12, over the log of 4. So 12 divided by 4, that is 3, so we have the log of 3. Part D, half log 4 minus log 6. So here we're going to apply the second law and the third law. So according to the third law, if you have n log of a, that is the same as the log of a raised to power n. That is what we're going to use for the first part. So we're going to have that as log of 4 raised to power half minus the log of 6. So you apply the second law, which says there's a difference of logs, there's a log of the quotient of the two numbers. So realize that this particular number is raised to power half, so that means we just get the root of 4. So the root of 4 is 2, so we have the log of 2 minus the log of 6, which is the same as the log of 2 over 6, which is just the log of a third. But we can rewrite a third using the laws of indices, such that if you have 1 over a, that is the same as a raised to power negative 1. So we can apply this to simplify this further. So this can be the same as the log of 3 raised to power negative 1. And then you again apply the third law of logarithms, so that we write this as negative 1 times the log of 3, which is negative log of 3. Example 4, evaluate the following. Part A, log of 64 to base 2. So here we are going to apply the fact that if the base and the number are the same, then that log is equal to 1. So all we are looking for is to get a situation whereby the base and the number are the same, so that we say that is 1. So we can write log of 64 to base 2 by rewriting 64 as a base 2. So that is what we are going to do. So we are going to have this as the log to base 2 of 2 raised to power 6. Then from there, we just apply the third law of logarithms, whereby we rewrite this as 6 log to base 2 of 2. So this is equal to 1, so that we have 6 times 1, and that is equal to 6. Part B, log to base 10 of 0.001. So again, we're going to look for a situation where the base and the number are the same. So this can be written as log to base 10 of 10 raised to power negative 3. And we can write that as negative 3 log to base 10 of 10. And since the base and the number are the same, this bit is equal to 1. So it means we have negative 3 times 1, which is just negative 3. Part C, log to base 3 of 1 over 27. So again, we can manipulate this expression so that we have a situation whereby the base and the number are the same. So we can write this as log to base 3 of 1 over 3 raised to power 3, which you can write as log to base 3 of 3 raised to power negative 3. And we can apply the third law of logarithm so that this is the same as negative 3 log to base 3 of 3. And since the base and the number are the same, that part is equal to 1. So it means we have negative 3 times 1, so that the answer is negative 3. Part D, we have log to base 1 over 3 of 9. So again, we are going to try and manipulate. Remember, we can only manipulate the number and not the base. So we're going to try and make 9 look like the base. So we can write that as the log to base a third. You can write 9 as 1 over 3 raised to power negative 2, which you can also write as the log to base a third. You can write this as 1 over 3 raised to power negative 2, because this power negative 2 can serve both. If you raise 1 to power negative 2, it is still 1. So you can write this as that. And then when we apply the third law, we're going to have negative 2 log to base a third over third. So now the number and the base are the same. So this bit is equal to 1. So it means what we're left with is negative 2 times 1, which is just negative 2. Part E, log 32 divided by log 16. So we can write this as a quotient. So we have the log of 32 over the log 16. So we can write 32 and 16 as a basis of 2. So 32 can be written as 2 raised to power 5. So it means you have log of 2 raised to power 5 over 16 can be written as 2 raised to power 4. So from here we just apply the third law of logarithms so that we have 5 log 2 over 4 log 2. So log 2 and log 2 can cancel, so that we're left with 5 over 4.